So it's my pleasure to welcome Jeremy Zigman, Principal Solution Architect from Kuiper. Jeremy.
There we go. Good morning. All right. Thank you guys for stopping by. Just to kick this off, I'd like to pose a question. And that is really, what would you do differently in your day-to-day operations if you knew that you had high-speed, low-latency, fiber-like connectivity anywhere you were going to take your operation in gigabit class? So we're going to walk through a few slides, talk a little bit about Kuiper, about the project, give you an update on our timelines, progress, and then we've got some open Q&A at the end.
Status check. Go Atlas.
Go Centaur.
Go Kuiper.
3, 2, 1. We have ignition and liftoff.
Okay, I guess I'm going to have to do a voiceover here. Rocket launch sounds, lots of tension.
Copy
Cool
that,
space
everyone.
backing track.
We got contact with both satellites. PH miles
Satellite
down.
picture from orbit. There we go. Okay, thank you. So Project Kuiper, our aim is to offer high-performance global connectivity that businesses can rely on. Keyword here is global, right? So today, if you're responsible for procuring connectivity solutions, fiber, LTE, satellite services, wherever you go, that procurement exercise tends to be burdensome, and you have to manage it through multiple providers, through the procurement, installation of hardware, fiber links. And our aim is really to provide, a single pane of glass, single user experience to provision global connectivity anywhere at the scale and kind of price performance inflection point that meets your use case, whether that's a few megabits for an IoT analytics type use case that you're going to wire up to some systems, all the way up to, gigabit class connectivity to run multiple HD streams for remote production, REMI, whatever that might look like. So let's take a look at some of the connectivity challenges today and talk through why we're doing this, right? Even today in modern times with relatively good high-performance connectivity everywhere, there are still pockets and areas where primary, secondary, backup, tertiary connectivity still don't exist, and we'll talk through those as we go through the whole continuum from rural to suburban to remote industrial type use cases. Looking at the urban environment, typically our urban city centers are well connected, but even with high quality and high quantity connectivity, there's still opportunities for disaster recovery for situations where you need high resilience, high availability, critical operations like hospitals, financial institutions, live media events where you've only got one shot. Moving out of the urban core and into the suburban environment, we still see relatively good connectivity. However, that connectivity is often interconnected back into an urban core through single points of failure that lack options for redundancy and have, upstream potential for tertiary cuts. When our friend the fiber-seeking backhoe shows up and cuts up the local fiber pop, the opportunity for non-terrestrial backup is there. Especially when you can deliver fiber class connectivity. Moving out into, kind of the rural and industrial market, these operations get very expensive. If you've got to take fiber, to a remote location, you're oftentimes looking at $100,000 or $1 million a mile in some situations for mountainous terrain. And so the opportunity to connect, these types of use cases that benefit greatly from connectivity for safety, for crew welfare, and for better observability and monitoring is really key. And then you got the folks that are really far out there, islands that have, single point of failure connectivity, be it subsea cables or satellite links, cruise ships, airplanes, things that move and operate in harsh or, oftentimes moving saline, dusty conditions. And what we'll talk about is really how we're building our terminals and our system to operate in these austere and challenging environments. Let's take a look at Kuiper Services. So before I go into that, one of the first things I want to talk about is really, at Amazon, we operate through leadership principles in everything that we do. And what that looks like, in priority one is customer obsession. And that's really why we're here, why Kuiper is here. We want to learn from this industry, learn how we can tailor and craft, our services to better fit your needs, and really hear from you on what that looks like. When we talk about long-term thinking and commitment to, operational excellence over time, Amazon thinks big and we think long-term. And Kuiper is really the embodiment of that leadership principle as we look at, securing the largest commercial space contract ever signed, over 80 heavy lift launch vehicles to put this constellation into orbit. And I'll talk a little bit about the timeline. This is a graphic depicting the constellation deployment. And really, there's a couple of things I want to point out here. The first is that you can see this constellation is deployed into 3 shells, 590, 610, and 630 kilometers in orbit. That's a little bit different from other constellations that you may have seen deployed. There's really kind of 2 benefits and values here. The first is safety, space safety. So when we're operating this many spacecraft in orbit, having multiple altitudes separates those spacecraft apart, creates a safer operating environment, and it requires us to use less fuel for station keeping. So it makes for a longer lifetime of the spacecraft and a safer operating environment. It also increases the density or the capacity of the constellation as it relates to you, the end user. So when you've got multiple shells and we're stacking those satellites in orbit, from any point on Earth, you can actually see more spacecraft at any point in time. That puts more capacity over that area, allowing us to support those gigabit class services in multiple locations. And it also provides resilience. Each customer terminal can see multiple satellites overhead. Each satellite can see multiple gateway stations on the ground. And you've got a resilient multipath network that's really building on Amazon's history and DNA in distributed systems design from AWS. We're carrying those principles forward into the Kuiper constellation. Operating in low Earth orbit means low latency. Being 590 kilometers away means that I've got a spacecraft within 10 to 15 milliseconds of me at all points in time. That means I can have round-trip communication back to an AWS region or a network that I'm interconnecting into in 30 to 50 milliseconds or less. And what that really means to you as the end user is that operations that you have connected into fiber today, you can lift and shift onto this service with no impact or refactoring of those systems. They just work, right? It's fiber-like experience. Let's walk through, kind of our progress to date, timeline, and when you can expect general availability of services. So back in 2018, Kuiper was founded. Just last year, on October 6th, we had our first protoflight. There we go.
I'm joining you from ULA's Advanced Spaceflight Operations Center, and today's launch is an exciting step for Amazon's Project Kuiper.
Launch sequencer start. Go Atlas. Go Centaur. Go Kuiper. You have permission to launch. Proceeding with the count.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition and liftoff of the United Launch Alliance Atlas V rocket, carrying the proto-flight mission for Amazon's Project Kuiper.
Mach 1. Vehicle's now supersonic. Everything's looking good. We have exited the Earth's atmosphere.
We go ahead and...
Yes, can run in parallel.
Copy.
2 minutes to contact.
Just want to she is alive.
Progressing nominally.
It's nominal on both Proto 1 and Proto 2.
Huge milestone. We got contact with both satellites. Both of them are alive. Still a bit to go. Take 5 minutes. We'll come back at 11:59.
Awesome. And that really marks the milestone of Amazon becoming a space company. So the first 2 proto-satellites that we put into orbit last year have demonstrated with 100% success all the systems that we're looking to implement across the broader constellation. Most importantly are the optical intersatellite links. So this proto-flight operation was meant to demonstrate a number of system capabilities, but we're most proud to mention, 100 gigabit link over about 621 miles or 1,000 kilometers. What that means, the optical intersatellite link, if you think back to that first graphic that I shared, that showed the mesh, the optical mesh, right? All of those satellites mesh together. That's a giant mesh network, and that provides, greater capacity, greater resilience, will allow us to serve a broad number of use cases. All of this is built on top of the AWS global backbone network and our regional set of infrastructure. So when we talk about, there's no compression algorithm for experience, really what we're doing is we're taking all of the decades of experience that Amazon has accrued in AWS, in our network design, in our regional cloud deployments, and we're bringing that into a LEO constellation to take all of those services and extend them through the LEO connectivity capability and build on top of the well-architected infrastructure of AWS regions. So anything that you're doing in AWS today, any type of connectivity solutions that you're using AWS for, you'll be able to extend and augment them with Kuiper very easily. That will allow for private and public data flows. So when we talk through, kind of the Kuiper system architecture, there's 4 key elements to talk through. The first is the customer terminal, which I'll go into a bit more detail here in a second. Customer terminals speak with our satellite segment over Ka-band RF spectrum. So that's a little bit different than some of the satellite communications that you may be familiar with. Ka being a more millimeter wave spectrum, RF spectrum, allows us for much higher throughput capacity to get up to, that gigabit class network speeds. And it also allows for much more precise application of the RF from the space segment down to the customer terminal, so we can create pinpoint spot beams and really provide, very dedicated and SLA-backed, service capabilities. The satellites communicate with our Kuiper ground station network. That ground station network, again, being built on the AWS global backbone. So all of those many hundreds of ground stations are interconnected into the AWS, regional backbone network to provide for high availability, resilient network that you can, build a business on and really trust. And then lastly, we arrive in the Kuiper network core running on AWS. And that's really where the magic happens. And we give you the ability to take all of the networking constructs and services available in AWS today and extend them through the Kuiper network. That means that if you wanted to have a private connectivity solution and direct connect right back into your production environment, right into your data centers and bring those video streams, over a completely private path so that you could ensure, performance and reliability, that's a solution that you can architect with Kuiper. We'll also obviously provide, public internet services, and, general just, kind of CDN type connectivity. Let's take a look at the customer terminals. So, these look kind of boring at first glance, but there's a lot going on here. And, really the design intent with these 3 different customer terminals is optionality and flexibility. So, you can go from a 100 megabit solution that fits in your backpack in our subcompact terminal all the way up to gigabit class performance on the enterprise terminal and really have the ability to kind of mix and match and fit those terminals to the use case so that you can get, kind of optimal price performance for what it is you're trying to do. So, as we talk about kind of benefits and use cases, this is not, just a kind of a consumer grade network, right? We're building a network medium in low Earth orbit, and the intent is to provide and service a number of different use cases and verticals from government connectivity, through, residential and consumer connectivity, through enterprise, use cases like media, operations. We're most interested in, speaking to you about what use cases you're interested in and how we might optimize the Kuiper network for them. Some that we're thinking about, things like field reporting, right? Where you've got crews, that are going to remote areas and trying to, report. Our capability gives you the Kuiper system gives you the ability to have multiple HD streams at one point in time, pretty much anywhere on the globe, from 56 north to 56 south. Live streaming, right? By bringing gigabit class connectivity to some of these some of these events that are in remote areas, we can provide, more social connectivity. We can tie, social networking into our video products, provide a more immersive experience, and really kind of integrate what media solutions might look like. Remote filming, camera to cloud, like Remy, right? These are kind of table stakes, right? The ability to take those streams and go directly into the cloud, directly into your production pipeline without having to touch anything else, or, do sneakernet with tapes or hard drives or other types of, cumbersome type of media. And then lastly, right, sports coverage. You can broadcast in HD from anywhere, multiple streams in HD, and really provide more immersive coverage on a broader scale without having to drag all the fiber, without having to drag all the equipment, put up and tear down. So, lastly, I just kind of leave you with these 3 bullets, and then we can have some Q&A if anybody's interested. Why Kuiper? What are we building? Why are we doing this? The intent here is really to be, a more high performance network that is enterprise grade, that you can build, solutions on top of that you trust, through, decades of experience in cloud computing, and is natively secure by design. I could spend an entire hour in this talk on just the security that's part of this network. So building on top of AWS, in our experience in cloud computing and security, we extend, AES 256 point-to-point tunnels. So anytime you're connecting a Kuiper terminal into your backend network, we're standing up a private slice through this whole network that allows you to put dedicated performance service plans onto that slice and really kind of tweak the security and the price performance that you're looking for. The Kuiper team is going to be hanging out here in the booth. So if anybody else has any questions, happy to field them. If you've got a solution that you're interested in implementing or have an idea, you can also talk to your AWS account team rep if you have one, and go that way. But we're here to talk, and I'm happy to, answer some Q&A.
Wonderful. Thanks, Jeremy. So we've got time for questions. Who's going to be brave and go first?
Fire away. Anybody?
Here we go.
So are we basically going to have a space direct connect? Is that what it'll show up as?
You can you can think about it that. The question there is, are we going to have a space direct connect? And for those not familiar with AWS, direct connect is the ability for you as a customer to bring your own direct connection into Kuiper, your own fiber network, and basically create your own private network with the AWS cloud resources on the other end. So the question is, can I have a space direct connect? Can Kuiper facilitate and be that direct connect right into my production environment? And that's exactly it. That's the architecture that we're thinking of. Yeah. Thanks, Zach.
Anybody else have questions?
I'm curious how, if you had that capability, how you would use it.
So does anybody have any interesting use cases they can share?
Anything that's not being supported today, or that you're not willing to put onto existing connectivity solutions like Cell or other satellite services today that just don't meet the performance or price mark.
So I've got a question for you. So clearly this is a media entertainment show. Have you come across any interesting questions yet from people that want to do anything particularly innovative with covering maybe live sports, live events out in the field that maybe traditional solutions have not provided the type, the flavor, maybe the price point of connectivity?
It's a great question. One of the questions that we run into with media and entertainment is, okay, great, you showed me these 3 terminals that can do 100 megabits, up to potentially a gigabit. What if I need more? What if I've got, multiple production streams that I'm trying to transmit? And for this to really be viable, gigabit's not even going to cut it. I need gigabits. What I would leave this group with, the Constellation is capable of much higher performance. This terminal set is really what we're bringing to market as the mass market terminals, right? We're leveraging Amazon's scale and experience in manufacturing devices from Alexa, Kindle, so on, and using those economies of scale to manufacture these terminals at a very attractive price point to hit really what we think are the price performance inflection points that cover most use cases. If you have a use case where beyond gigabit would be, where we would need to start the conversation, we do have some off the menu options that we can talk about, and would be happy to have those conversations, around those use cases.
Okay, so any final questions at all before we wrap up? All right.
Stay tuned for more. This project has been kind of in quiet mode, with our proto-flight launch being kind of the first, public advertisement. We are now entering our production launch cadence, and we'll begin launching those 80 heavy lift rocket launches to put the constellation in orbit. So you'll see a lot more coming soon. And if you have any use cases that you think might be interesting, we'd love to talk to you about it.
What a fantastically interesting subject, Jeremy. Thank you so much. And please, ladies and gentlemen, give Jeremy a round of applause.
Thank you.